Hi, this is Dr. Green, and we are looking at some homework examples for homework set 1 here for Math 111. So these problems should be very similar to your homework exercises, so you should be able to watch a problem and then work a problem, and watch a problem and then work a problem. And then stuff that you know how to do, of course, you can just forward the video and skip over, and then you can rewind it if you need to also. So now just be aware though that your problems are not going to be identical to these examples, but they should be very similar. So let's get started. Here in problem number 1, they want us to find the intersection of a couple of sets here. And remember that intersection means overlap. The key word there is and the intersection symbol looks like an N, which is in the middle of the word and. And so we want all the letters that are in both of these sets. So A is in the first set but not in the second. S here is in the first and in the second. And then U is in the first set and in the second. Z, first set but not the second. So that intersection, that overlap, the stuff that's in both sets is S and U. Okay, so this is in both. And that is answer C. So that one's all set. And if I don't think they have you do union, but remember union looks like this, and union unites the set, so it keeps everything that's in both sets, but without repeats, whereas intersection is the overlap. In problem number 2, we want to use order of operations here to simplify this expression. And let's go ahead and take this expression. Let me bring that down here, right here. And remember our order of operations is PEMDAS is the acronym. And remember that stands for parentheses, exponents, multiplication, division, addition, subtraction. So that's please excuse my dear Aunt Sally. Or if you're talking about my son when he was in 6th grade, this was please exterminate my doofus antagonizing sister. They had their moments. So first thing to recognize when we're simplifying this expression is that that whole numerator needs to be simplified and the whole denominator needs to be simplified. So there's some understood parentheses that are not written. So we want to simplify like that. So putting those parentheses in, we're working inside the top, inside the bottom separately. Next, we want to look at exponents. So any exponents we can simplify, and there's one here, 3 squared. So let's go ahead and do that. So numerator, I'll just rewrite here. Absolute value 4 minus 10, and then minus 2 times 1 minus 4. And then in the denominator, 4 times 9, 3 squared is 9, minus 3 times 10. Okay, so what's next? Well, let's go back here. We got parentheses inside of parentheses here, and then the absolute values, look, they act like parentheses. So we got to simplify inside those first. So let's do that next. So this will be on the top 3, and then the absolute value of 4 minus 10, that's going to be the absolute value of negative 6, minus 2, and 1 minus 4 is going to be negative 3, so 2 times negative 3. Okay, so those inner parentheses are done. And now let's do multiplication, division, left to right. So inside the top and inside the bottom, multiplication, division, left to right. So I am going to take this subtraction here and change it to add the opposite. So now I've got 3 times the absolute value of negative 6, which is actually 6. Absolute value of negative 6 is positive 6. So this is 3 times 6, which is 18. And then plus negative 2 times negative 3, positive 6. And in the denominator, 4 times 9, 36. Minus 3 times 10, 30. And now, still working inside parentheses, only one operation left, addition. So 18 plus 6, 24. And inside parentheses on the bottom, 36 minus 30 is 6. And 24 divided by 6 is 4. And that's answer B. Now, if you have a calculator that does order of operations, as long as you insert these parentheses here, it should simplify that in the right order. Of course, your calculator might not do absolute value. So that could be an issue. Oh, and by the way, one nice calculator to use is the MyScript Calculator. That's an app you can download. It's available for both Android and iPhone. And what you do is you write the problem out with your finger, just like this, just like you see it on paper, and it computes it. And I'm not sure if it does absolute value, but I know it'll do everything else here, and it should obey order of operations for you. So download that app. That'll be really nice. It works really well on a tablet. You have to be a little bit more careful on your phone if your screen is small, because you're writing with your finger. Sometimes it confuses things. And in problem number 3 here, we've got this bar graph here that's looking at student population for a small university from years 2005 through 2015. So notice how this decreases and then it increases. So they had some time where student population was decreasing and then increasing. And this looks almost like a parabola, part of a parabola, which is an x squared curve. And actually they tell us here that student population, P, is modeled by this equation 36x squared minus 667x plus 5450. Okay, so and that is an x squared curve, which is a parabola pointing right side up. And what they want us to do is use that formula. Oh, by the way, here, x is years after 2000. So here in 2005, x equals 5, for example. And they want us to use that formula to find the student population for the school year ending 2011. So that'll be x equals 11. And then by how much does the formula underestimate or overestimate the actual student population? So let's scooch down here a little bit. So I've got the graph here. And then I brought that formula down that estimates the population. And we want to look at 2011. So in 2011, that tells us that x is equal to 11. And then that means that the population given by the model is going to be 36 times 11 squared. And then minus 667 times 11, and then plus 5450. So 11 squared is 121, so this is 36 times 121, and then minus 667 times 11, and plus 5450. So now if you go ahead and plug this into your calculator, you will get 2469. So that's the forecast. That's the estimate. And then the question here is, by how much does the formula underestimate or overestimate the actual? So is the formula an underestimate or an overestimate? Okay, well, the actual in 2011 here is 2530, and the estimate was 2469. So it's an underestimate, so we can cross off these overestimate possibilities. And then was the underestimate by 43 or 61? Well, let's see here. 2469 was our estimated, minus 2530 was our actual, And if you subtract those guys, you will get negative 61 on your calculator. So the negative is indicating it's an underestimate by 61, which is choice D. So as long as you do the estimate minus the actual, if it's negative, it's an underestimate. If it's positive, it's an overestimate. So I can't remember what your problem does, but just do estimated minus actual. Negative is under, positive is over. So this is negative, over would be positive. All right, and problem number 4, we are going to downtown Chicago here, and it takes you 45 minutes to get there, and you spend t, is your variable, t minutes driving to the train stop, and then the rest of your time riding the train into the city. So a lot of people ride the train in because traffic is, terrible getting into Chicago, so they'll ride a certain ways and then they'll ride the train in. And then you can walk around downtown pretty quickly. So let's say your driving rate is 0.75 miles per minute, and this wouldn't be the bus, the train. I think in your problem you're doing a bus. Train travels at 1.05 miles per minute, and because they don't have any traffic stops, they don't have any traffic jams, so they can travel faster. Total distance driving and traveling by train is given by this expression. Okay, so this is our distance in miles. So the 0.75 times t, that's your driving distance, and then the 1.05 times the time that's left. 45 is your total, so 45 minus t is the number of minutes left. That's your total distance by train. So distance driving plus distance train is your total distance. And they ask us simplify the algebraic expression and use it to determine the total distance if you travel 25 minutes driving. So that's saying t equals 25 is what that's saying, because t is your driving time. Okay, you spend t minutes driving. Okay, so let's go ahead and simplify this expression first, and then we plug in t equals 25. So our distance here is going to be 0.75 t, and then we want to multiply that 1.05 in. So 1.05 times 45, just key that in on the calculator, and you will get 47.25. And then 1.05 times negative t minus 1.05 t. And then these guys, those are like terms. So positive 0.75 and a negative 1.05 will give you a negative 0.3. So this is negative 0.3 t. And then we've got that 47.25 left over. So there's our simplified expression. And so now our driving distance here, if our driving time is 25 minutes, that means our train time is 45 minus 25, 20 minutes on the train, is going to be negative 0.3 times that 25, and then plus 47.25. And if you key this into the calculator, you will get 39.75. And that is choice A. So again, I think yours is the same idea. They give you the expression. You just have to simplify and substitute the value in. I think yours, in your example, you're going by bus instead of train. All right, problem number 5, we are doing some simplifying of an exponential expression. So 2x to the 5th cubed. So that means this expression is multiplied by itself 3 times, or by laws of exponents, if you've got things that are multiplied to a power, you can take the power on each piece. So we can take that 2 and cube it, and then multiply by the x to the 5th and cube it also. So 2 cubed, 2 times 2 times 2 is 8, and x to the 5th cube, that's a power to a power, so you multiply exponents. So 5 times 3, 15. So that's 8x to the 15th, which is choice C. And that one's all set. So you should be able to do something similar. Take the power on each piece, power to a power, you multiply exponents. And number 6, we are writing in scientific notation this number. So with scientific notation, you want to have one number to the left of the decimal and then the other numbers to the right of the decimal. So that means our decimal needs to go right here. So this is going to be 4.483. And then it's times 10 to a power. And the power is how far you move the decimal. So the decimal was here, so we move 3, 6, 9, 12, 15 places to the left. So that's going to be a positive 15 power, and it's a positive power because this is a very big number. If it's a negative power, that's for very small numbers, like 0.0000005. So 4.483 times 10 to the 15, which is B. Now notice that some of these other things are equivalent, like this is actually equivalent because you did 0.44 and then you increase the exponent to 16. So if you key these into your calculator and ask them if they're equal, it's going to tell you they're equal. But this is not proper scientific notation. With proper notation, you want one number to the left of the decimal. Okay, one number left of your decimal. And then this exponent is the number of places that the decimal is moved. And it's going to be a positive exponent if you've got a big number, and it's a negative exponent if you have a small number. All right, so that one's all set. Number 7, we're performing some operations with scientific notation and writing the answer in scientific notation. So you actually can do these on your calculator. If you're using the MyScript Calculator, you can just write it out exactly like this. Now, if you are not using that calculator and you don't have scientific notation on your calculator, the easiest thing to do is just to download the app or get a calculator that does scientific notation. But the other way to do this problem is to say, well, what this means is 7.5 over 2.5 times 10 to the 12 over 10 to the negative 4, right? Because if you multiply these fractions, you multiply straight across the top and straight across the bottom, and then you'll get this. And 7.5 divided by 2.5 is actually 3, because 3 times 25 is 75. And we can include one decimal place there because we've got one decimal place here. And then when you divide two exponentials where the base is the same, you subtract exponents. So 12 minus negative 4 is 12 plus 4 is 16. So that's 3 times 10 to the 16th, which is choice D. And if you just straight enter that in the calculator, that should be the same thing you get. And you'll know for your problem that you're doing the right thing if you get this answer correctly on the calculator. And again, it's understood here, whole numerator divide by whole denominator. Those parentheses are typically not written. And number 8, let's see here, according to the U.S. debt clock here, the national debt's about $21,180 billion, and we're writing that in scientific notation. Okay, so 21,180 billion, so it's going to start out 21,180, and let's see here, if we had 3 zeros, then this 180 would be 180,000. If we had 6 zeros, then that'll be 180 million, 21 billion 180 million. So you need 3 more zeros. And now this will be 21 trillion 180 billion, because billion is going to have 9 zeros after it. So remember, what we want is one number to the left of the decimal, so the 2 and then the decimal place. And then we've got 1180, 1180. And how far do we move the decimal? 3, 6, because it was here. 9, 12, 13 places. So this will be 13th power. Whoops, I need my times 10 on there. Times 10 to the 13. There we go. And so 2.118 times 10 to the 13. And if we look over here, that is choice C. 2.1180 times 10 to the 13. So 13 places that the decimal was translated. Number 9, we are working with some radicals here, some roots, and we want to use the product rule to simplify this expression. We're assuming that the variables are representing non-negative real numbers, so that means x here is going to be greater than or equal to 0. So remember, the product rule, what it lets you do is it lets you multiply these things together underneath one root sign. So we can do this. This is going to be the square root of 3x times 24x cubed. So then 3 times 24 is, let's see, 60, 72 looks like. So it's just going to be square root of 72. And then x times x cubed is x to the 4th. Okay, and that is one of our answers, but that's not simplified, because we've got some perfect squares in here that we need to take out. So remember, what you want to do is you want to break this apart into all the perfect squares that you can. So the biggest perfect square that goes into 72, 72 is actually 36 times 2. I mean, it's 8 times 9, but then 9 is a perfect square, but 8 is 2 times 4, and 4 is a perfect square. So we want 36 is the biggest square that goes in there. And remember, you can just list those out if you want to. You know, 2 squared equals 4, 3 squared equals 9, 4 squared is 16, etc. 5 squared is 25, and 6 squared 36, and keep going. And the biggest square that goes into 72 is 36. Goes in there twice. So we're going to break that 72 up as root of 36 times 2. And then the x to the 4th, that's got perfect squares in there too. That is x squared times x squared. And each of those are perfect squares. So now we can break the product apart and take the root of each piece. So root of 36 times root of 2 times root of x squared times root of x squared. And square root of 36 is 6. It's the number you square to get 36. The root 2 we have to leave on the end, can't simplify that, but square root of x squared, the thing you square to get x squared, is x. And then here's another x, so this is x, and then this is x. So that's x squared. And now it's simplified. 6x squared root 2, which is choice A. So you want to make sure you pick the simplified answer. You've got to take out all the perfect squares. There's no more perfect squares underneath the root sign. And let's see, number 10, we are rationalizing the denominator. So we want to get rid of that root that's in the denominator. And remember, the trick here is to multiply the numerator and denominator by the same expression, but with a plus sign. So that's called a conjugate for the radical. And if you multiply it out, then you'll get rid of your root here. So root 5 plus 1 over root 5 plus 1. So on the top, we're just going to leave that as 3 times the square root of 5 plus 1 in parentheses. In the denominator, though, we're going to go ahead and FOIL this. So square root of 5 times square root of 5 by the product rule, that's going to be square root of 5 times 5, so root 25. Outer terms here, plus root 5. Inner terms, negative root 5. They cancel. And then last terms, negative 1 times 1, minus 1. So that's actually 3 times root 5 plus 1. And then square root of 25 is 5 minus 1. 5 minus 1 is 4. So 3 times root 5 plus 1 over 4, and that is choice C. Now watch your sign here. This is plus 1. This is minus. Don't mark the wrong one. Okay, the sign should actually be different. Should be the opposite of what you started with. This is negative, this one's positive. If this was positive, then you'd use negatives here, and this would end up being negative. And there's no more roots in the denominator, so that was rationalizing denominator. All right, let's see, halfway there. Number 11, simplify. So simplify the equation using properties of exponents. So we're multiplying here. When you multiply, you're going to add exponents. So 4 times 5, that's 20. And then x to the 2/5 times x to the 1/3 is going to be x to the 2/5 plus 1/3. So you're going to add those exponents. And so it's going to be 20 and x to the 2/5, and leave a little bit of room there, plus 1/3. And we got to get a common denominator for those fractions, which is just 15. So here we'll multiply top and bottom by 3 over 3, and in this piece multiply by 5 over 5. So now this is 2 times 3, 6 fifteenths plus 1 15th. So this is 20x to the 6 fifteenths plus 1 15th. I'm sorry, 1 times 5, 5 fifteenths. Multiplying straight across. And 6 plus 5 is 11 over the LCD of 15. So this is 20x to the 11 fifteenths power, which is B. And we're all set there. And let's see here, number 12. This formula J equals 2.3 root x plus 22.3 models the projected number of job openings, J, in millions, where x is years after 2010. Use the formula to find the projected number of job openings in millions from 2015 to 2030. Express the difference in simplified radical form. So they want to do the difference in the number of jobs here. So, well, x equals 0 corresponds to 2010, so 2015, that's 5 years later, so there x is going to be 5. And 2030, that's 20 years later, so their x is going to be 20. So we want to plug a 20 in here, plug a 5 in, and then subtract them. Okay, so that difference, the difference in number of jobs, is going to be 2.3 times square root of 20 plus 22.3. So that's the number of job openings here in 2030. Minus, they want us to subtract off the number of job openings in 2015. So that's the same expression, 2.3, but now square root of 5, because x is 5 in 2015, plus that 22.3 on the end. And remember, subtracting here, that's going to distribute that minus sign in here. So this is going to be 2.3 root 20 plus 22.3, and then minus 2.3 root 5, and then minus 22.3. So distribute that negative sign. And then these guys cancel. So they're done for the day. And we've got now 2.3 root 20 minus 2.3 times root 5. And notice that's not one of our answers here. Okay, so we've got some more work to do simplifying. And notice that 20 is 4 times 5. So this 20 is 4 times 5. So root 20 is going to be root 4 times root 5. That's a times there. So this is going to equal 2.3 times root 4 times root 5. So you used product rule and broke that 20 up. Minus 2.3 times root 5. And then square root of 4 here is 2. So this is actually 2.3 times 2, which is 4.6. So 4.6. And then we've got square root of 5 left. Minus 2.3 root 5. And those are like radicals. So you can just subtract the coefficients here. So this is like 4.6x minus 2.3x. So you just do 4.6 minus 2.3, which is 2.3. But it's not x, it's root 5. So 2.3 times square root of 5, which is a. Okay, so they want that difference simplified. 13 is not a lot of trouble. Find the degree of the polynomial. So that's the highest power in any term here. The highest power term is 6. So degree of that polynomial is 6. So this is the highest power. So that one is not tough to do. And then in 14, we are finding a product of this expression. And so we got two binomials that we're multiplying. So we want to do first terms, we want to do FOIL. So first terms here, 3 times 4 is 12. And then x cubed times x cubed, when you multiply, you add exponents. So 3 plus 3 is 6, so 12x to the 6th. Outer terms here, 3x cubed times 2 is going to be 6x cubed. So plus 6x cubed. Inner terms, negative 4 times 4x cubed, so negative 4 times 4, negative 16 x cubed. And then our last terms, negative 4 times positive 2, negative 8. And then these guys are like terms, so combine those. So 12x to the 6th. Positive 6 and negative 16, negative 10 x cubed. And then minus 8. And that is choice D. So you should have something similar there. And in number 15, they give us another model. So the model for the number of people n that have seen a particular advertisement at time t is given by this expression. Well, actually, I guess that should be time x since the expression is in x. So at time x is given by 4.1 x to the 4th plus 2.0 x cubed minus 0.5x plus 1.3 plus 3.8 x cubed minus 7.1 x squared plus 0.9x minus 4.5. And they say simplify the model. So what they want you to do here is combine your like terms and add those two polynomials. So we've got an x to the 4th term here, nothing over there. Okay, so if we simplify this, let me go ahead and bring this guy down. We will have a 4.1 x to the 4th, x cubed term here, and an x cubed term there. So we add the coefficients. 3.8 plus 2 is going to be 5.8 x cubed. No x squared term here. We got an x squared term there. So minus 7.1 x squared. minus 0.5x here, plus 0.9x. So negative 0.5 plus 0.9 would be plus 0.4x. And then we got a 1.3 here, minus 4.5. So positive 1.3 and a negative 4.5 is going to be negative 3.2. And this expression here is right here. Is choice B. So they'll be just giving you two polynomials that they want you to combine like terms. Write the polynomial in standard form that models or represents the shaded area. So shaded area out here, so that's going to be the bigger rectangle minus the smaller rectangle. Okay, so this bigger rectangle is x plus 10 by x plus 6. So this will be x plus 10 by x plus 6. And then minus, take out the smaller rectangle, which is x plus 8 by x minus 2, height. Just doing base times height here. And notice that expression is here in choice A, but they say write it in standard form. This is not in standard form. They want us to multiply things out and collect like terms. So we got to do FOIL here. So first terms, x squared. Outer terms, 6x. Inner terms, 10x. That's 16x. Last terms, 60. And got to be a little bit careful here. This multiplication comes before the subtraction. So minus first terms, x squared. Outer terms, negative 2x. Inner terms, positive 8x. That's plus 6x. And last terms, negative 16. And now we are subtracting the expression, so we're going to change the signs in here and add. So it'll be plus, it'll be minus, minus, plus. So we've got x squared plus 16x plus 60, and then minus x squared minus 6x and plus 16. So the x squareds cancel. And then we've got 16x minus 6x is 10x. And then we've got 60 and 16 is 76. So 10x plus 76 is standard form, which is choice C. Okay, so don't fall for that, that first choice there. Okay, getting close here. Number 17, factor the polynomial by grouping. Okay, so by grouping, I see these first two terms here have a common x squared, and the last two terms have a common 3. So it looks like we can group these first two terms, and then there's a plus sign, so I don't need to do anything putting the parentheses in around the last two terms. So common x squared here we can factor out. So if we factor that x squared out of x cubed, there's an x left. Minus, that's this minus sign. Factor the x squared out of here, a 5 is left. Plus, factor that 3 out in front, and x is left from the first term. Negative 15 divided by 3, negative 5. And then notice that x minus 5 is a common factor, so we can pull that guy out in front. And if we factor that x minus 5 out, there's an x squared left here. Factor this x minus 5 out, there's a plus 3 left there. And x squared plus 3, that doesn't factor any further. So x minus 5, x squared plus 3, looks like choice B. And here they want us to factor a polynomial using the formula for difference of cubes. And I've put that formula down here for you just for demonstration. And what you want to do is you want to make this expression look like the difference of two cubes. Well, the y cubed is already set. Y cubed looks like a cubed. But the thing that you cubed to get 64 is 4. So, and if you didn't know that, you could do cube root of 64 on your calculator. So 4 cubed is 64. So here our a is y and our b is 4. So in the formula, wherever there's an a, put y, and wherever there's a b, put 4. So this will be y minus 4, and then a squared, that's going to be y squared, plus ab, so y times 4, 4y, and then plus b squared, and b is 4. 4 squared is 16. Okay, so y minus 4, whoops, this should be y squared. Y squared plus 4y, because a is y, and a gets squared, so y squared. Y squared plus 4y plus 16. So notice it's 2 terms times 3 terms, so these guys are out. And then these both start out y minus 4, but this is plus plus, this is minus minus. We want plus plus, okay, which is choice C. Got a local department store going out of business. See a few of those, too many of those lately it seems. They've reduced the prices on their merchandise by 60%, and then those sale prices got reduced by another 30%. So a lot of times that happens. You know, they'll lower prices, and then as it gets closer and closer to closing time, they lower them some more. So if X is the original price here, the sale price can be modeled by, and so they give us this expression, x minus 0.6x, and then minus 0.3 times x minus 0.6x. So where that's coming from is x is your original price, and then they mark stuff down 60%. So 60% of x is 0.6x, and they subtract that off. So that's the first 60% markdown. And then they take 30%, another 30% off of that. So they subtracted 0.3 is 30%, but it's not 30% of the start x, it's 30% of this discounted price. So that's what's inside the parentheses here. So directions are simplify the expression, and then at what percentage of the original price is, looks like we're looking at a computer here, is our computer selling here. So we're looking at a computer that was at a going out of business sale. And so with these two reductions. So well, if we simplify this expression, it'll tell us. So x minus 0.6x, and then minus 0.3 times x minus 0.6x. So let's take this negative 0.3, we'll multiply it in here, and then we'll combine our like terms. So we've got out in front x minus 0.6x, and then negative 0.3 times x, so minus 0.3x, and then negative 0.3 times negative 0.6 will be positive 0.18, and then that's also times x, which is your original price. So now we've got a whole bunch of like terms here, so we just combine the coefficients. So 1 minus 0.6 is 0.3, I'm sorry, 0.4, and then 0.4 minus 0.3 is 0.1, and then plus 0.18 would be 0.28. So this actually simplifies to 0.28x. So 0.28x is 28% of x, is what that is. So this is 28% of x. So whatever those original prices were, after the two markdowns, we're at 28%. And if we look over here, 28 is choice D. So 28 is the percentage of the original price on this item. So, and yours will be similar. They'll give you the expression, you just want to simplify it, and whatever that decimal is, that's telling you the percentage of the original price. All right, last problem. We want to write an expression in factored form for the area of this shaded region. So you've got a big square here that's 5x by 5x, and then you've got 4 smaller squares that are taken out. Okay, so the larger area is base times height, 5x times 5x. And then you subtract out 1, 2, 3, 4 squares that are 3 by 3. So 4 squares that are 3 times 3. So that's going to be 5 times 5, 25. We don't know what x is, so x times x, x squared. 3 times 3 is 9 here. 4 times 9, 36. So minus 36. So 25x squared minus 36. Notice that is one of the answers, but it says factored form. Okay, so we got to factor this. So notice that 25 and x squared are perfect squares, and so is 36. So notice that 25x squared is really 5x quantity squared minus 6 squared. So this looks like the difference of squares formula, a squared minus b squared, where your a is 5x and your b is 6. And remember that this factors as a plus b times a minus b. So wherever there's an a, we plug in 5x. Where there's a b, we put in 6. So this will be 5x plus 6 and 5x minus 6. And that is choice C. Okay, so yours should be similar. They just changed the numbers, but don't forget to factor. Okay, so bigger square minus 4 little squares, and then factor difference of 2 squares. All right, very good. You should be able to do all those homework problems, and hopefully you get 20 out of 20.